Hello and welcome back to Ronnie Explains. So in this session, I'm going to take you through the process of designing circuit of a counter machine. And our counter machine is going to be operational in 3 bits. And we are also going to use a D-latch. So in the future videos, I'll also be teaching you how to design the same machine using a JK flip-flop. So let's delve into it. So if you look at the screen, this is how this circuit of the counter should look like. So this is the final work. So we are going to begin by making a documentation in a spreadsheet document where we design the truth tables and fill out the kernel maps, then come up with all the logical expressions that we require to complete all this work. So let's dive into it. So in my Google browser, I will come to my Google Drives and then I will open a new spreadsheet file. So I'll come to new and then come to Google Sheets. So over here, I have this workspace. So I will be working in binary, therefore I need to record my states. And my first state here, I am going to record them from 0 to 7. And it is because of a very simple explanation that if we are operating in 3 bits, then it is workable from 0 to 7. So we'll be having 0, then 1, then I'll simply drag this 2 down here. The last one is not required, so I'll just remove it. Then over here, I'll write the equivalent of these values in binary. So here I will be having 0, 0, 0, henceforth up to the final one. Now realize that over here, I will be having my values from A, B, C, D towards this other side. So here I will have A, then I'll have B, then C, then D. So equivalent values in binary. This column here will contain zeros all through up to here. Then on this other column, the first 4 will be zeros, so I'll just copy this and paste them here. Then the next ones will be 1, so I'll just type 1 and drag it down. In the other side, we'll be having a pair of zeros and ones, so I'll copy this and paste it here. Then again do the pasting on this other side. Then in the last column, I'll be having again 0 and 1s following each other, so I'll just copy this and paste it here severally. Then maybe copy the whole of it and paste it down here. So this is what we have for the current states, and I will represent the current states using a capital letter N, just to make sure that everything is okay. Maybe I'll center it, but somehow later. So this other side, the next states, I'll represent them by N plus 1, and I will be having A out, B out, C out, and D out. So then how this will be working is very simple. If we are having state 0 here, it means the next state is supposed to be 1, and therefore we'll be going to this state. So I'll copy these states that we are having here and then paste them in this place like that. Then the first one, which was the 0th state, is supposed to be copied and pasted down here. So just to make sure that everything is center aligned, I'll just highlight everything, then come to justification and align them at the center like that. So for distinction, I'll just have to give the current states a different color, maybe color green, and then the final states, I can represent them by color orange. For this one here, maybe I can give it a color like color blue, and then I can give this one maybe color yellow. So these are my inputs, and these ones here are the outputs. It means that this machine is a sequential machine, so it works with memory. If it is in state 0 currently, then if it wants to go to state 1, it should always remember that it's in state 0 and the next state should be 1. So it kind of have a memory element, and that's why it's a sequential circuit. Just so you know that in the column of D, we have zeros all through, and that explains the reason why D is useless. This column and this column is useless, and therefore this machine will be operating in 3 bits, where the ones are only existing in the column of C, B, and A. So the next process is to make the kernel maps, and I'll just design the kernel map somewhere here. So it will be a 4x4 kernel map. So I'll just use that. Then I'll merge these values here. Then I'll also merge this, and then merge that, and finally I'll merge this. So the first one that I merged is A, this one is B, this one is C, and this one here is D. I'll also do some few things in the column of A here. On the right border, I'll enhance the border and also give it a different color. So I'll come here and then highlight the right border. I'll come to the color and give it red so that it becomes distinct, and then increase the line weight like that. So that's how it looks like. In B, I'll do the same with the left border. So I'll come here and then go to the left border. In C, I'll work with the bottom border. So I'll come here and then select the bottom border. Then in D, I'll also do the same with the top border. So I'll come here, then I fight with the top border. So here, C and D should be justified at the center just so that it appears presentable. So I'll just come to justification and align them at the center. And then A should be aligned towards the right. So I'll just put it there. Now, all of them should be boldened for easy visibility, and that's what I've done. So this kernel map here, I can copy it and paste it. So I can copy and paste it 3 times. So I'll come and paste it here. Then I'll also paste it down here. And then finally, I'll come and paste it down here. So I have the 4 of them. The first one will be representing the value of D out. Then the second one will be C out. This one, then the third one will be B out, and the last one will be A out. So I have to fill in the values here. So this is how I'm going to fill the values. For D out, it will be equal to some logical expression. So all values are 0, and because of how I filled the values of the truth table, I began filling A, B, C, D from the right towards the left, like this. And therefore, when I'm filling in my kernel map, I'll fill it in this fashion. I will fill here 0, 0, 0, 0. Then this other side also 0, 0, 0, 0. The middle values will be don't care values because I am not interested in any number that is greater than 7 because my counter is supposed to be counting from 0 to 7, bearing the fact that it's working in 3 bits. So it means this part will be x, 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 and also here will also be x, 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 and that's how it looks like. So just to align everything at the center, I'll just highlight that and come to my justification and align them at the center like that. Now we don't have any ones here, and that means that when we'll be forming the groups, we'll have 0 groups here because we can only form groups with ones. Therefore, the value of D out will simply be 0. It means it will be useless in this case. Then the next kernel map here is the kernel map for C out. And in the kernel map for C out, I'll fill in these values. The first ones that we have is 0, 0, 0, 1. So I will come here and fill that values as 0, 0, 0, then 1. And then the next ones will be 1, 1, 1, 0. So this other side, I'll have 1, 1, 1, then 0. So that's what I have. And just the same way we did with the D out, the middle columns are going to be excess because they are don't care terms. And then we have to align everything at the center so that it matches what we did for D out. Now, while making the groups for this, I'll identify the largest groups as possible, and I will have to treat the don't care terms as ones where necessary. So the first big group that I can see here is this group here. I will give it a color, maybe orange. Now this group here, it is entirely out of A, so therefore it is going to be A prime, and it is partly in B, so B is not an option. It is entirely inside of C, and therefore here we'll have C, and it is also partly in D, and therefore D is not an option. So then we connect that with the next group using an OR gate. The next big group that I can also see is this group here, and that group I can highlight it in a purple color. Now this group, the purple group, is partly in A, so therefore A is not an option. It is completely out of B, and therefore we'll be having B prime, and it is entirely in C, and therefore here I'll have C. Then the next group that I can see here is this group over here. I will give it maybe a blue color, and that group, connecting it with an OR gate to the rest of the groups, it is entirely in A, and that's why here I'll have A. It is entirely in B, and that's why here I'll have B. Then it is entirely out of C, and that's why I'll have C prime here. And that's how we form the groups for this kernel map of C out. So moving on to the next one, we are going to move on to B out. Now, if you look at B out, its column is this one. So just for reference, I'll have to freeze some few things here. So I'll come to view, then I freeze some rows, and I'll freeze up to, just wait, view, freeze, rows. Then I'll just come and highlight this up to here. Then I'll come to view, freeze up to 11. then I can easily manipulate this lower part without having to scroll the whole Google Sheet. So B out is this column here, and the first values that we are having are 0, 1, 1, 0. So here I'll have 0, 1, 1, 0. And then the next values will be 0, 1, 1, 0. So here I'll have 0, 1, 1, 0. Then the middle values will be excess because they are don't care terms. And then I will center everything like that. Sorry, they are centered. Everything like that. And then I'll form my groups. So the two large groups that I can see here, the first group is that, and the next group that I can see is this group here. So the orange group is entirely out of A, and that's why that's A prime, and it is entirely in B, and that's why it's B. I connect it with an OR gate to the next group, which is the green group. The green group is entirely in A, and that's why here I will have A. And it is entirely out of B, and that's why here I will have B prime. Then that is how we form the groups for that kernel map. The next kernel map here will be the kernel map of A out, and we also have to feed in its values. Its values are for this column here, and the first values are 1, 0, 1, 0. So here I'll have 1, 0, 1, 0, and then this other side also I'll have 1, 0, 1, 0, and the middle values will be excess. So that's why I have them as excess like that. And then I'll just center align all of those inputs. So therefore, I have to make the largest group possible, and the largest group that I can see here is this group. So I'll just give it a green value, and then I have to look at it. It is entirely out of A, and that's why here is A prime. It is partly in the others, and that's why we don't regard the others. So these are the logical expressions that I've come up with. And if you look at them keenly, then you realize that the value of D out is 0, and therefore it won't play a part when it comes to making our logic circuit. So therefore, we have to proceed to our software and start designing the circuit. So before that, I'll just come here and unfreeze this. So I'll come to View, then I will freeze no rows. That's how it looks like. So I will come here and launch my software, and then I'll set up some few things. In layers, I'll come to and check instant labels and also check port labels. Then I will come to view, then I zoom it at 0.7. Then again, I come to magnetic grid and use 1/8 inch. So this is how my design page has been set up. So therefore, the next thing that I need to do is to bring in my latches. I'm working in 3 bits, and that's why I'll be bringing in 3 latches here. So I'll come to create flip-flops, and then I will use DFFR. So I will paste it here 3 times. Then I will name this as C, then name this as B, and finally name this as A. Maybe I'll just zoom it so that we are able to see it clearly. So just zoom this region. So this is how it looks like, C, B, and A. I have to work out the logic on this other side. So therefore, I'll just minimize this window towards this side and then bring my spreadsheet document towards the right. So the values of C are A prime C, B prime C, and ABC prime. So I have to check the two input AND gates, all of them. So we have this A prime C and B prime C for the first one. So I'll just put them somewhere here. Right click, create gets, then AND gate two inputs. So I'll have it here as 1 and 2. Then the name of this one here will be A prime C. Then the name of the second one will be B prime C. And the next values will be ABC prime, and it is a 3 input, so I'll create gets a 3 input AND gate. So I'll have it there. Its name is ABC prime. And then I will move on to the next. The next one is for B out, and it also has 2 input AND gates, and that's A prime B and AB prime. So just so you know that A prime B and AB prime is the same as A XOR B. For simplicity, I'm not going to use an XOR gate, so I'll just use an AND gate. So just B out. So I'll come here, right click, create gates AND gate, and then I paste it here 2 times. So this one here, the name is A prime B, and the name of this here is AB prime. Then the last one is A prime. It's a single signal, and therefore I don't require any AND gate to implement that. So then the next thing that I'm going to do here is to combine the groups with some OR gates. So the first group, which is C out, is going to be combined using a 3 input OR gate. So I'll create gates OR gate, but 3 input. Then I just bring it somewhere here. Just to move it a bit, we'll just move it there. Then I will connect this here, connect this here, and also connect this here, because A prime C, B prime C, and ABC prime, all of them, they belong to C out. So the name of this is the names of these 3 AND gates. So it's A prime C, or B prime C, or ABC prime. Then just say OK. The next one will be a 2 input OR gate. So I'll just create gates and a 2 input OR gate, and then I will just put it somewhere here. Then I connect this here and also connect this one here. So then the name of this is going to be A prime B, or AB prime. So that's what I'm having. Now I'll have to come this other side and connect this D-latches to these gates, but with regards to the logic. So all A primes will be connected to A prime, so I'll just come here, then connect all A primes that I have. So the first A prime is here, and the next A prime is here. So I'll just connect this like that. Then the next that I need to connect is A, so I'll connect A here, and then I'll add a wire segment and connect this other A here. Then the next that I need to connect is B prime, so I'll have this, connect it to this B prime, and then I'll also connect this B prime over here. So wire, add segment, and connect this B prime. Then I'll connect the B's. The first B is this one here, so I'll just come here and connect it like this. Then the next B is this one, so I'll come here, add a wire segment, and connect it here. And then I'll move to C prime. The only C prime that I have is this C prime here. And then I'll move to C. So then in C, I'll have this one here, the first AND gate, and then I'll also have another C down here, this C here. So I'll just come here and connect it here, this C, and those are the only C's that I have. Now, if you look at all the ports, they have been connected. Then now, I'll just come here to view and zoom fit, and maybe zoom it out a bit. Then on this other side, because I know that this one is the value of C out, I'll have to connect it to the C latch. So the C D-latch. So I'll just come here and connect it to the input of this here. And this one is the value of B out, so I'll also have to connect it to the B one. So I'll come here. So the B D-latch, it will be connected over here. Now for A, we know that A is the expression, the logical expression is A prime. So A prime is this wire over here. So I'll just connect it from here. I'll add a wire segment. Then I'll move down, come here, and then connect it over here. So that's connected. Then I will have to bring in the automation part of it, where I will bring in my clock input. So I'll create a pulse switch to act as my clock, and I'll put it somewhere here. Then down here, I'll also create a reset button. So I'll come to create IO, then IPN switch will act as my reset button. So this, I'll name this here as clock, and then I'll name this here as the reset, like that. So this one over here this clock will be connected to all the clocks. So the first clock is here, then the next clock is here, this the clock inputs, then the next clock input is here. So all of them have been connected. Then I'll also connect the reset buttons. So the first reset button input is here. Then I'll also connect this reset here, and I'll also connect this reset down here. So I've connected all of them. What I need to do next is to have my output values. So what I'm going to do here is to just come up here and create my output LEDs. So I'll right click, create IO, then output LED, and paste it here 3 times. So this, and that. Now the first one here, the name will be C out. Then this one here, its name will be B out. Then the last one, which is this one here, the name will be A out. So I'll connect C to C out, B to B out, and A to A out. So I will come to C, which is this latch here, and the values of C are flowing in these wires here. So I'll come here and connect it from this point. So I'll add a wire segment, and then I will just come and connect it to this one here. Then for the B out, I'll also come to B. The values of B are flowing in this wire, so I'll connect it from here. So I'll add a wire segment, then I will come here and connect it over here. Then the final value, which is the value of A, is flowing in this wire. So I'll come over here, I'll add a wire segment, and then I will come and connect it over here. So if our circuit has been designed well, and hopefully it has been designed well, then we shouldn't have any errors. So I'll come to options and check design. So it tells me the design is okay, no errors have been found. So say okay. And have to test it if it's giving out the correct values. So I'll come to my certain clock. So I'll come to clock and activate it. Then I come to reset and then I click it. So everything has been reset. So if I just expound on this here and then come to view and zoom fit so that we can see the whole of the circuit, this is how it looks like. When it's at state 0, then we are having these ones as 0. And just so maybe to reduce the window once more so that we cross-check with what we had in our truth table, then this is what we are going to be having. So I will come here and just reduce the size of this for purposes of viewing these ones in a better way. So I'll just come and resize just a bit like that. And then I move it this side so that you can see everything. Then I'll also come here to view and zoom fit. So right now it's at state 0 here. So if I click the set, then this is how it looks like. So it's at state 0. The next state is supposed to be 1. So this other side is showing 0, 0, 1. Then again, if I click the clock, it goes to 2. So this is 0, 1, 0, the same as here, which is 0, 1, 0. Then again, if I click it, it goes to 3, which is 0, 1, 1. So this is 0, 1, 1. Then if I click it once more, it goes to 4, which is 1, 0, 0. So that's what we have. Then again, if I click that, goes to 5, which is 1, 0, 1. Then if I click it again, goes to 6, which is 1, 1, 0. Then again, if I click it, goes to 7, which is 1, 1, 1. If I click it again, it goes back to 0, which is 0, 0, 0. So that's how the circuit of the counter has been designed. Just to save it, I'll just come here to Ctrl+S and then save it in a new folder. And this new folder, I'll call it counter device. Just say maybe counter is sufficient, maybe counter 1. Then I just say open. So inside here, I'll name this one here as a sequential counter, like that. Then I will save it. So it has been saved. So I'll come to files, then open new file. And on this space here, I have to confirm if my instant labels and port labels are okay. So all of them are checked, so it's fine. Then I'll come to view and use zoom out 0.7. Again, view, I'll come to magnetic grid and set it to 1/8 inch. So in this space, just right click and create it sub-design, or create a sub-design of this, and this is what I have. Sub-design is rather small, so I'll just have to zoom it out. So I'll just zoom region and zoom this region here. So this is how it looks like. On this other side, I'm going to bring in, I'm going to create an hexadecimal display and just put it somewhere here. Then on this side here, I'll come to create, and then I'll create a clock generator. I'll put it over there. Then here I'll create the reset button. So create a OI pin switch and put it here as a reset. Just name this as clock. Then I'll name this as reset. Then I'll just do the connection like that. Also this like this. Then C out will be connected to that, B out will be connected to that, and A out will be connected to that. Now we realize that B, the value, the three input port is not connected, and it shouldn't remain like that. So I'll just come here and create another IP switch, but it should always be off anytime that we are operating this counter. So I'll just put it somewhere here, and then I'll connect it like this, and then this one here should always be turned off like that. So I'll come here, this other side, and maybe just zoom fit it. Then I'll activate the reset and then activate the clock. Then I come to reset and just set it so that we see how it operates. So it will be counting from 0 to 7 and then goes back to 0 and start counting again. So this is how we can create a sequential circuit of a counter machine, and the logic as you've seen. If you have any questions, then you can type it in the comment sections. And then if you have any questions that you want me to address, my email is also still in the description. You can email me, then I will see how best to help you with your questions. So thank you for watching. If you haven't subscribed, then consider subscribing for more informative contents. And until next time, I hope to see you.